Claire, I wonder how TVs work.
That's a good question. The first moving image transmitted through television in 1909 when a signal was transmitted to an 8x8 pixel screen. During this time, the cathode ray tube was the most common television, which only transmitted black and white motion pictures. In 1964, the first working liquid crystal display, or LCD television screen, was created. This brought color to television. Experts were concerned for the amount of radio wavelengths the transmission would need.
This is a cathode ray tube. It is a vacuum that is used to display images on a screen. The electron beam is the stream of electrons that is generated by heat or charged atoms. Deflection coils are a part of the electron beam with the purpose of creating a changing magnetic field. Cathode refers to the negative terminals. In the CRT, it is a heated filament. Focus anodes turn the flow of electrons into a thin beam. Accelerating anode attracts the electrons and moves them toward the screen. The phosphorescent screen aids in producing light for the display. Looking on a controller, the light at the top of the remote sends infrared rays to the television.
Using the speed of light equation, we can solve for the frequency of infrared light between a remote and a TV. The equation is C equals F times wavelength, where wavelength is represented as lambda, F equals frequency, and C is the constant speed of light. The given values we have are the constant speed of light, which is C equals 3.00 times 10 to the 8th meters per second, and the wavelength of infrared light is 940 nanometers, which is also 940 times 10 to the negative 9th meters. And we're solving for frequency. With the given values, we can start plugging in the values to solve for F. The speed of light, which is 3.00 times 10 to the 8 meters per second, equals the frequency times the wavelength, which is 940 times 10 to the negative 9 meters. To solve for F, divide over the wavelength. F equals 3.00 times 10 to the 8th meters per second, divided by 940 times 10 to the negative 9th meters. The final answer is F equals 3.19 times 10 to the 14th hertz.
The two main kinds of newer version TVs are plasma TVs and LCD TVs. The main difference between the two is that plasma TVs have pixels that light up much faster than LCD TVs, making the images brighter and more clear. A plasma screen TV is made up of thousands of tiny pixels. Each pixel is made up of 3 brightly colored lights that are blue, green, and red. Each pixel cell is filled with neon and xenon gases. When electricity is applied to the pixels, the atoms inside the pixels crash around inside and produce invisible ultraviolet light. The phosphor coating in the pixel turns the ultraviolet light into visible light that is seen on the screen. This is a diagram of the layers that make up a plasma TV. The first layer that is labeled is the address electrode. The xenon and neon gases are situated between the two electrodes, one of which is being labeled. Address electrodes are usually behind the cells and right next to the panel closer to the back of the TV. The rear glass plate is labeled next to the address electrode. The next layer is the phosphor coating, which is what turns the ultraviolet light into visible light on the screen. The next layer is the display electrode, which is on the other side of the phosphor coating, which acts as a barrier with the address electrode. The last layer on the TV is the glass plate in the front. I get it now.
It all makes sense.